Good morning everyone. I am Prasanna. I am from first year CSE department. Today I am discussing about extrinsic semiconductors p-type. Introduction. P-type semiconductors are materials that have been doped with elements that create holes or positive charge carriers. This presentation will explore their properties, mechanisms, applications and significations in electronics. Definition. Materials with conductivity between conductors and semiconductor insulators. These two are types of p-type semiconductors: intrinsic semiconductors, extrinsic semiconductors. Intrinsic semiconductors, pure semiconductors; extrinsic, doped semiconductors. This is the example for n-type p-type semiconductors. Introduction to p-type semiconductors. Definition. P-type semiconductors are created by doping intrinsic semiconductors with accepted impurities such as boron. This process results in an excess of holes that can carry positive charge. What is electron-hole pairing? In p-type semiconductors, when energy is provided like heat, electrons can jump to the conduction band, leaving behind holes which serve as the primary charge carriers. Doping elements. Common doping elements include boron, gallium and indium. These elements have favor valency electrons that silicon, allowing for effective hole formation. Formation of holes. These are three formations of holes. Mechanisms of hole formation. When an acceptor atom interacts with silicon, it creates a hole when one of its electrons participates in bonding with the silicon atoms. This absence of an electron creates a hole. Concentration of holes. The concentration of holes in a p-type semiconductors is depend on the doping level. A higher doping level increases the number of holes, enhancing conductivity. Temperature effects. The temperature can affect hole mobility at higher temperatures. More electron-hole pairs are generated, thus increasing conductivity. Characteristics of p-type semiconductors. These are three characteristics of p-type semiconductors. Electrical conductivity. P-type semiconductors have good electrical conductivity due to the movement of holes. The holes allow for the flow of current, functioning effectively in electronic devices. Energy band structures. In the energy band diagram, the valency band is filled and the conduction band is mostly empty, highlighting the presence of holes, majority and minority carriers. In p-type semiconductors, holes are the majority carriers, whereas electrons are the minority carriers. P-type versus n-type semiconductors. Firstly, what is charge carriers? P-type semiconductors utilizes holes as charge carriers, while n-type semiconductors utilize electrons. This difference significantly affects device functions. Doping elements. While p-type semiconductors use elements like boron, n-type semiconductors typically use phosphorus or iron, which are more electronegative behavior in electric fields. In an electric field, holes in p-type material move towards the negative terminal, while electrons in n-type move towards the positive terminal. Applications of p-type semiconductors. These are the applications of p-type semiconductors. Transistors. P-type semiconductors are casually in fabricating PNP transistors, which are essentially components in amplifying and switching signals in electronic circuits. What is diodes? P-type materials are used in forming p-n junctions that are integral to diodes, allowing current to flow in one direction and enabling various applications including rectifications. Solar cells. In photovoltaic voltaic cells. PTF semiconductors help create junctions with N-type materials, enabling sunlight conversions into electrical energy. Future trends in PTF semiconductors research. Advanced doping techniques. Research is ongoing to find more efficient and environmentally friendly doping methods to enhance the performance of p-type semiconductors. 2D material applications. The explorations of two-dimensional materials for p-type applications is gaining traction, potentially leading to breakthroughs in electronics. Sustainability in productions. Development of sustainable practices in the manufacturing of p-type semiconductors is gradual for future electronic devices. Conclusion. P-type semiconductors play a key role in electronic devices. Doping with trivalent atoms introduces holes, mainly used in diodes, transistors, and solar cells. Future innovations may improve efficiency and stability. Thank you.